Hello. On this small video, we analyze Faraday's experiment. Michael Faraday conducted a very simple experiment to prove that moving magnetic field or a changing magnetic field can produce electric current. And the experimental setup is this, that a laminated wire is made into the form of a coil, and the two ends of the coil are connected to a galvanometer. Galvanometer is an instrument used to detect the presence of current, however small that be. Now he took a magnet, bar magnet, and he moved the north pole towards the coil. He pushed the north pole slowly towards the coil. Then it is found that a small current is developed in the coil. That means the galvanometer shows a small diffraction. So as he moved the north pole towards it, the diffraction is found to go in one direction. He tried the experiment with pulling the north pole away. As he pulled the north pole away, again there is a diffraction is found. And he repeated the experiment, keeping the magnet static and moving the coil towards and away. Then again he observed that there is a current produced in the coil through the deflection produced in the galvanometer. Then he tried by keeping it static, both static, no deflection is found, and he made both to move in one particular direction. Both the magnet and coil is moved with equal speed. Again, there is no deflection is found. So from this he identified that whenever there is a relative motion between the coil and the magnet, only then there is a current produced in the coil. And he tried one more thing. He moved the magnet slowly initially, then he made this coil static and the speed of motion of the magnet has increased. He moved it quickly towards it. That quick movement is made to induce a large current in it. That means the deflection in the galvanometer is found large. Okay? So from all this, what he identified as that relative motion and also the speed of motion of the magnet will be affecting the current which is produced in the coil. So from this small experiment, Faraday understood or identified or proved that varying magnetic field can produce electric current, and that was the beginning of what you call electromagnetic induction. Now let us see how this is being produced. See, for the magnet, you can see that the magnetic field lines are going like this. Magnetic field lines start from the north pole and going into the south pole. Okay? So many number of magnetic field lines are going like this, starting from north to going. So as I move the magnet towards the coil, these magnetic field lines are linking with the coil. And those field lines, when it is linked with the coil and as you move it, the field strength is found to be varying. That means there is a varying magnetic flux linked with the coil. That varying magnetic flux is the cause which is producing the current to be produced in the coil. Okay? So if a current is produced in the coil, that means that there will be an EMF developed across the ends of the coil. Those EMF develop, we call it as induced EMF. And the current so generated, we call it as induced current. Okay? Induced EMF and induced current. So based on this experiment observation, Faraday defined two laws known as Faraday's laws of electromagnetic induction. Whenever we discuss the name Faraday, there are many different things will be coming related to this name. For example, in electrolysis, there are Faraday's laws of electrolysis coming. So in many fields, we are seeing the name Faraday. So when you use the name Faraday, you must be specific about which field it is. So here we are going to see the Faraday's laws of electromagnetic induction in the next field.